On 11th May 2021, NASA released clips of the James Webb Telescope opening its mirrors for the last time on Earth. But what is the James Webb Telescope mission and why is it so important? Welcome to Insight Media. James Webb Telescope is an orbiting infrared observatory that will complement and extend the discoveries of Hubble Space Telescope, but with longer wavelength and greatly improved sensitivity. It is a large infrared telescope with an approx 6.5 meter wide primary mirror. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 and played an integral role in Apollo program. The launch was initially planned for 2007, but since then the project has had a number of delays and cost overruns. The JWST underwent a major redesign in 2005 and was finally completed in 2016. But in March 2018, NASA delayed the launch after the telescope's Sunshield ripped during a practice deployment. Work on integration and testing of the telescope was suspended in March 2020 due to the COVID-19 pandemic. Now the launch is scheduled on an Ariane 5 rocket from French Guiana in 2021. Amidst all of this, the budget of the Wide Hole mission has skyrocketed up to $10 billion. Webb is an international collaboration between space agencies such as the NASA, European Space Agency ESA, and the Canadian Space Agency CSA. The NASA Goddard Space Flight Center is managing the development effort, while the Space Telescope Science Institute is going to be the operational center after the Space Telescope is launched. Webb is set to be the premier observatory of the next decade and is accompanied with cutting-edge technologies, making it the biggest space mission of humankind till date. This includes a primary mirror which is made up of ultra-lightweight beryllium, which is divided into 18 separate segments that unfold and adjust to shape after launch. But the Webb's biggest feature is a tennis court-sized 5-layer sun shield that attenuates heat from sun more than 1,000,000 times. The telescope has 4 instruments including cameras and spectrometers capable of detecting and recording extremely faint signals. Another instrument called NIR spec has programmable microshutters capable of observing up to 100 objects simultaneously. Now, since the JWST is said to be one of the most prestigious missions, what about the Hubble Space Telescope? And how does this both telescope differ? These days, Webb is called as a replacement for Hubble Space Telescope. But as per NASA, Webb is actually the successor of Hubble Space Telescope, as it would raise the standards for space exploration to a whole new level. The Webb and Hubble mainly differ in the terms of spectrum of light. Hubble can detect visible spectrum, whereas Webb is built to peep into the infrared spectrum. This is due to the fact that the more distant objects are highly redshifted and their light is pushed from UV and optical to a near infrared spectrum, and thus to observe these distant objects like the first galaxies formed in the universe, it is necessary to have an infrared telescope. Another difference between Hubble and Webb is that Webb has a much bigger mirror than Hubble, making it capable of seeing further back into time. Also, Hubble is in the close orbit around 570 kilometers around the Earth, while Webb will be 1.5 million kilometers away at the second Lagrange point. But why is observing in the infrared observation important in astronomy? Stars and planets that are just forming lie behind cocoons of dust that absorb visible light. However, infrared light emitted by these regions can penetrate this dust and reveal what is inside. For example, this image. The image in the right is taken in the infrared spectrum, whereas the left one is taken in the visible range. The infrared image clearly shows presence of more stars and galaxies than the visible image counterpart. The JWST will be orbiting Sun at a distance of 1.5 million kilometers away from Earth at the second Lagrange point. Lagrange points are positions in a three-body system where the gravitational pull of the two large masses precisely equals the centripetal force required for small objects to move with them. The orbit is selected specifically to let the telescope stay in line with the Earth as it moves around the Sun. It is necessary for Webb to be shielded from any bright hot sources, as the telescope will be observing in infrared wavelength and it can detect very fine infrared signals of very distant objects. Thus, any other interruption of light would hinder the observation. The balance of the combined gravitational pull of Sun and Earth at L2 point means that Webb will keep up with Earth as it gets around the Sun. Also, unlike the Hubble, which goes in and out of Earth's shadow every 90 minutes, Webb will have an unimpeded view that will allow science operations 24/7. JWST is scheduled to be launched in 2021 on an Ariane 5 rocket. Ariane 5 is one of the world's most reliable launch vehicles capable of delivering Webb to its destination in space. JWST will be launched from Ariane Space ELA-3 launch complex at the European spaceport. In order to fit into the launch vehicle, it is necessary for the telescope to fold itself. As the rocket will reach its maximum acceleration, the two solid rockets will detach itself, reaching the upper atmosphere. Where the protection is not needed, the covers would detach away. The first stage detaches after the ignition stops. The second stage ignites to resume its journey to L2. To avoid damage to the telescope due to the sun's heat, a series of oscillations are performed to provide necessary protection. Near the end of the powered flight, the roll program stops and the launchers then assume the proper altitude for separation. The telescope now continues its journey towards the final orbital while performing necessary adjustments. The solar array is the one to be deployed first. Completed, all of Webb's electrical power necessities are satisfied by the solar array for the remainder of the mission. The onboard central system continuously monitors and updates the altitude to ensure power generation and safety. To preserve the cleanliness of the mirrors, the thrusters are located only on the sunlit side of the observatory. If course corrections are needed, these velocity additions must be included only in the early flight procedures to ensure efficient use of the limited fuel. 2 hours after the launch, the high-gain antenna will be deployed. After 3 days, the major deployment stages start, starting with the aft Sunshield pallet, followed by the tower that separates the telescope and the instruments from spacecraft. Next goes the aft flap deploys. This is a key to managing momentum built up in fuel consumption after attaining the final position. After attaining the final position, the membrane launch systems are released. Then the mid-boom extends and the Sunshield attains its hexagonal tennis court size shape. The membranes are then tensioned. Now the secondary mirror deploys and takes its position. Then the aft deployable radiator springs into position. The cord-fold wings deploy and latch into their places, thus completing the deployment of the largest and most prestigious telescope of mankind till date. A trajectory correction is applied 29 days after launch to put the telescope in its halo orbit. The Sun-Earth L2 point is where the Webb's orbit around the Sun is synchronized with Earth, thus freeing the Webb from the thermal influences of Earth and all eclipses. Additionally, the Earth, Sun, and Moon, the brightest objects in the sky, are hidden by the deployable Sunshield, giving Webb a dark, cold, and stable environment to carry out its mission of discovery. Till 6-1, the different equipments on the Webb are turned on one by one along with the alignment of the mirrors and testing and calibrating of the equipment. After 6 months, the Webb will begin its science mission and start to conduct routine science experiments.